Hi guys, welcome back to the channel. And for our usual housekeeping, this video is sponsored by Digilent. Thank you, Digilent. And as always, all thoughts and opinions expressed in this video are mine and mine alone and do not represent those of any company I am currently or have previously been associated with. So let's get into it. So a few videos ago, I went over the process of how I create a test setup for my electronics projects on a bench that is all connected to a host PC such that everything can be remotely controllable via that PC or a PC remoted into that PC. I got a lot of great feedback on that video, and some of the feedback I got was that I forgot to actually show myself going to a different computer to remote into the PC that the whole setup was connected to. So it didn't seem quite as remote as the project was capable of doing. Now, while I could go back, set that benchtop setup, and then show myself going to a different computer remoting in, that wouldn't be a super long video. So I kind of had it in the back of my mind that I wanted to do another remote test setup. And that's when I saw a series of data acquisition boards to use on the Raspberry Pi on Digilent's website. Now, to switch gears a little bit, I'd been having a concern in my camping setup in my car. I like to go car camping to get away from all of the work things. I had a concern of something about my setup that I wanted to start monitoring. So in my whole little, I have my sleep setup, I have my little portable fridge, and then I have like a big camping battery to power that fridge, and then it's also got some like USB ports and other plugs on the front so I can charge my phone and stuff. And on a particular camping trip, the battery had gotten fairly low, probably like in the 5 to 10% range. And the way I have it set up is the fridge is plugged into the battery, all the other stuff like phone chargers plugged in the battery. But then the battery also has, on its charging port, it has a DC car plug, like the old cigarette lighter looking plug. And my car, because it's kind of meant to be an overlanding type vehicle, has a 12-volt DC plug in the rear trunk area. So I keep the battery plugged into the 12-volt outlet in the car so that when I'm driving, the battery can always be topped off and kept charged because the car only powers that DC plug when the engine's running, obviously to keep from killing the battery. So, like I said, on this particular camping trip, the battery had gotten fairly low, and I was driving back home when I stopped to get a drink out of my mini fridge. And that's when I noticed the actual charging plug in that 12-volt DC plug was significantly hot. It made me worry. Now, I will say the power management circuitry, both in my car and inside the battery, definitely did its job. I didn't blow any fuses, I didn't cause any damage to the car, the battery is totally fine. That plug was hot enough, it just worried me, because obviously the battery, being at such a low charge state, had to pull extra current, pull extra power to get itself back to a fully charged state. So because it's a concern, I would like to keep an eye on it. So when I saw these data acquisition boards on Digilent's site, the thermocouple version of this board stuck out in my mind because I want to measure temperature. So I decided that a Raspberry Pi with this thermocouple on it would be a great way I could have that attached to both the plug in the trunk, and then I'd also have a second one monitoring the ambient temperature in the car because it's also summer now, and I also don't want the car, if the car is getting too hot, I need to bring the battery in or take it out of the car if it's getting too hot. So I have the Pi with the thermocouples it's talking to via the data acquisition hat. And ironically, that same battery is a perfect constant power source for the Pi, so those two elements are checked. Now, the only thing left that's needed is a way to access the Pi to see the temperature readings on the thermocouples. Now, I immediately thought of my other project from a couple different videos ago, which was the digital menu that I created for the coffee shop. That was based on a Python Flask web server running that customers accessed by scanning a QR code. Now the difference here between that project is the FPGA that was running the web server there was able to be on the coffee shop's Wi-Fi at all time, and the web server running on it was accessible via a public-facing port on the network. There's no Wi-Fi in my car, so I also need to have the Pi create its own wireless access point. For this particular project, I'm using a Raspberry Pi 3B+, so it does have an integrated Wi-Fi chip. The DAC hats are compatible with, I think officially up to Pi 4. They should have Pi 5 compatibility soon, and then if you're using an older Pi, you could just use a Wi-Fi dongle. But having the Pi create a wireless access point that I could then connect to from my phone or whatever device I want to. Furthermore, I don't want to have to SSH into the Pi every time I want to check the temperature on the device. So I also need to create a service that after the Pi boots up and has the wireless access point up and running, it automatically runs the Python script for the web server. So just to recap everything on this project, for hardware we have the Raspberry Pi with the data acquisition hat and our thermocouples that we'll put into the car, and there's 4 elements to the software for this project. There is the actual Python drivers and C drivers that talk to the data acquisition hat itself to take the thermocouple measurements. There is the Python Flask web server. There's creating the wireless access point, and then finally creating the service in the Linux image on the Pi that automatically runs the web server once the Pi is booted up and has that access point running. So I figured I would go through the software side of things. I did run into a couple interesting hiccups and show you how I got all that up and running, and then we'll take it out to the car and show it in action. So let's get into it. So just to give a little bit more background on the data acquisition hats on Digilent's website, there are 4 different options available, plus a PMOD adapter that can be placed on the top level DAC hat, because you can stack these. They actually come with 3 little headers here that you can create a 3-bit address for each one of them. The one that's on the bottom or directly connected to the Pi always has to be address 0, so that's why I don't have any jumpers on this one. But they all have 24-bit ADCs on them and can sample up to 100 kilosamples per second, which is plenty for our temperature measurements here. Furthermore, there are detailed instructions for how to install the actual drivers on the Raspberry Pi to communicate with all of the different data acquisition hats. It's a pretty simple process. As you can see, it's just cloning the repo, running the installation script, and then using the pip Python package installer to install the actual package. We'll get into that here in a minute, but I wanted to go over how I created the wireless access point, because I discovered a new thing since I've last done this. Last time I did it the manual way, and I discovered this new, and this has been around for a little while. This is not new, it's just new to me, but this RASP app, or Raspberry Pi Access Point. It's this really awesome software. It creates actually its own web server that's also running on the Pi. You can do several different things with this. Create bridged modes, extend your Wi-Fi, create a portable router. But by default, once you install it, it automatically just has a wireless access point that is up and running on the Pi after that permanently. So I can just install this and I don't have to do anything extra, even though it has quite a vast swath of features afterwards. So if you have not heard of RASP app before, I highly encourage you to check it out. Its installation is also very straightforward as well. The quick install, which does work with the latest version of the Raspberry Pi OS that's currently available. You just simply update everything on your Pi, You do want to run sudo raspberry pi config and change your WLAN location to your current country location. So I changed it to the United States for me. And then you simply run their quick installer. And then once that's done completing, it'll ask to reboot the Pi. And once the Pi reboots, this is all the default info for being able to access both the wireless access point it creates. So by default, the SSID of the access point the Pi will always create is RASP app. And then it has a default, Wi-Fi network has a default password of change me. You obviously want to change that. I'll show you that here in a minute. And then once you once you connect to that wireless access point from any device, you can do it from your phone, any of your computers. This IP address is where they have the web server running. That is the configuration tool. That's what this is. It's the configuration tool for the rest of the network. So the first pitfall I found here that I think is worth mentioning is I have the Raspberry Pi Imager. So things have gotten very plug and play since I initially started using the Raspberry Pi. This is awesome. So I chose Raspberry Pi 3. I chose the default 64-bit of Raspberry Pi OS. It's a Debian port of Bookworm, and it's the recommended. Now, since the RASP app software itself is going to create a wireless network that's up and running for you, I found that normally when I create a new Raspberry Pi image, I go ahead and have it configure the wireless LAN in the Raspberry Pi image itself. So then it boots up and goes into what's called managed mode. However, the issue with this is that will be the dominant protocol, and actually RASP app will come up and it'll start the wireless access point. It'll be there for a minute, and then when the configured wireless LAN that you've set here comes up, it'll overwrite it and just connect to the wireless network it's looking for as normal. So make sure that you leave wireless LAN unchecked here when you flash the SD card for this. Now, if you're a savvy Linux user, you could absolutely still leave this checked and then just change those settings in the OS itself. But I found, just for ease of use, since I'm not connecting to any Wi-Fi on a regular basis, I just found it was easier to leave this unchecked for now. So once I got that all set up, now to install RASP app, even before you call their quick installer here, even if you do have your Raspberry Pi connected to Wi-Fi, you do have to have the Ethernet, you have to be hardwired into your home router before you start the installation process for RASP app. But I figured I would go ahead and boot up and SSH into, oh, that's the USB port. So I'd go ahead and boot up and SSH into the Pi just to show you a few other pitfalls that I found. And then also show you the actual wireless access point. So we'll just give that a moment to boot up. And I typically, like I mentioned in my last remote setup video, the way I see in that video I was monitoring the current draw of the Pi to see when it was done booting. Here, since I don't have a current monitor, I'm just going to see, can I ping it? Ping it yet? Yes, I can. So that means it's booted. So I can SSH, a little moment there, my user at, and I always use raspberrypi.local, so I won't have to remember the IP address. So now that we have the Pi up and running, we can come to take a look at the web server, the RASP app web server. So before I switch my computer over from my Wi-Fi to the wireless access point on the Pi, just to show you that configuration, I did want to mention this had moved on me where to set the WLAN location or country. So that's in. So before you actually install RASP app, run the Raspberry Pi configuration editor, then come down to localization options, and then WLAN country. Just make sure you set this to whatever country you're currently in or going to be using it in, and then go ahead and run this series. Or well, the second command is what we just looked at, but then go ahead and call the RASP app quick installer. So I'm gonna go ahead, and I do have, since the Pi is booted up, that means the RASP app should be available, which we do see it here. We'll let it connect. It's gonna dump my SSH connection, but that's okay. So let's go ahead and copy the IP address here and come over to. So you've got the administrator login. So this is the default here. So that default is admin and secret. I've already come in and changed this and customized it to my password. Try this. I set different passwords for the admin login versus the Wi-Fi it creates. I had to remember which, but. So this is super cool. It gives you a status icon here. It says WLAN up. I've got one client connected, which is my MacBook that I'm on right now. And then it's getting external internet from the Ethernet port. What's really cool right now about this access point is my computer still technically has external internet access because the Pi has external internet access. That was a cool feature I also found. But if you want to change any of these settings, see, I forgot where. Oh, where it was in. So if you click on the admin user up here in the upper corner, this is authentication. This is where you change that login screen. So still the user was admin, and then the old password by default is that secret password. And then you can put your new password in here to actually log into this portal. That's super important because if this is up and on the public facing internet right now, anyone could Google that, see it, get into it. So definitely change this login password. And then back here on the, where was it? Was it the Wi-Fi client? To change the actual, like I said, I just started using this. Where is, I just saw it. Oh yeah, so under hotspot, you have your basic settings of which interface you want to use on the Pi. So if you want to change this to WLAN 1, like say if you had different, like multiple Wi-Fi chips on here, you can change the SSID. I just left it as the default RASP app. And then here is, oh, I'll have to blur that. But here under the security tab is where you can change your PSK, is the password to log into the network. And then it's got a cool little QR code that's just this same IP address to log into this web server on your phone if you were also connected to the hotspot. So let's switch back to, I'm gonna switch back to my internet so that we can go back to our SSH session on the Pi and go over a couple things that I found about the DAC Hat software. So now I'm back on my Wi-Fi, back to the Raspberry Pi. I'm SSH'd into it. So let's take a look at what else is in this repository for drivers to talk to the thermocouple data acquisition hat. So like I said, I've already gone through this process over here of cloning the repo, actually installing it. But what's also in that repo are some examples. So let's take a look at the DACats and then examples. And there's both examples in C and in Python. I'm using Python here. And the thermocouple, now if you look at this, list all of these. There's the different DAC hats that are available. The MCC 134 is the thermocouple that we're using. So if you list this again, so we've got some different, like a utility script, And then they've got a single value read Python script that's great for testing the hardware. So we'll run that real quick. And when that comes up, press enter to continue. And as you can see, the script is really cool. There's 4 channels that you can connect thermocouples to on the thermocouple hat. This script will go through and measure and see which channels don't have any sort of load on them. So that's why channels 2 and 3 are marked as open, because I have my 2 thermocouples on channels 1 and 2. And then just every second, it's taking a measurement of each one. So since we're just here, you can see that's why we're taking measurements. It's around ambient 25 degrees C here in this room, and we can then just Control C to kill that app. So that's super handy that script's just in there. You can call that from anything else you want, but I found that to be super helpful for just making sure my hardware's alive, that I don't have any problems, that I've gotten the thermocouples hooked up correctly. I did actually have the leads backwards initially, but I did also notice, and you've probably also noticed, that there is a web server already in here. So if you change directories into web server, there's already a web server script, a Python Flask web server in here, which I didn't realize that going into this, but that was just like bonus points of, oh, awesome. I didn't actually have to write any of the Python to interface with the DAC hat myself. However, it is very well documented. I do want to point out here in the MCC DAC library, I just got super lucky that my project needs were already met by the example scripts. But as far as how to use each of the functions, what functions are available, they're very well documented here on the Doc.io site. So while I don't have any pretty coding to show you in this particular video, we're just ready to up and go out of the box. So I'll go ahead and run that and show you, kind of already showed what it looked like before. Oh, it might be mad at me because I already have it running because my service is running. So let's just come over. It got mad at me because it was already, my service had already started it at boot up. But normally that's how you would start it manually. But what it does is on port 8080, whatever the Pi's local address, so this is the Pi's local address on my network here at home, which is what it's defaulting to now. I do also have it connected to, all of its IP addresses on port 8080, so including that same port on the wireless access point. Getting a little bit ahead of myself, I'll show you that code here in a minute. But anyway, so this web server example is actually exactly what I need. I come here and I can say how many channels I have, or how many thermocouples I have. I can set the number of samples display on the chart here, how many times per second I want to sample. So if I configure and then start, it might still be mad at me because I tried to run it twice. Sorry, I had to reboot there because I tried to run it again and made everything mad. Or yeah, because I forgot this is my final thing I have everything on. So my service at boot up started the web server, and then when I tried to run the web server again, I had a clash there. So I configure and then start. And as you can see, I've got my chart here measuring from my 2 thermocouples. Now my hands are a little bit cold, but this is channel, which one was that? Channel 1? I should see some change there. As I start to, there we go. See, as I hold it, starts to get warmer. And so I think that's suitable for what I need, since I just want to use my phone to connect to that access point, and I can see what the temperature looks like here and plot the little chart of what it's looking like. If I weren't lazy, I'd probably go in and maybe convert the table to Fahrenheit instead of Celsius, but just need to get better about what Celsius looks like, because I'm an American. I'm normally in Fahrenheit. we'll go ahead and stop that. Now, this uses, so even though the actual web server is using the Flask Python package, the web interface itself is using Dash. Now, the thing that I ran into, and I don't know if this is some sort of like recent incompatibility or what happened, but I did notice that there is, because there's two packages, two supporting packages. There's the typing package and the typing extensions package that Dash uses to create its web interface. So when I initially tried to run this, I was getting an error that there was some sort of package missing, or the typing extensions couldn't find a certain attribute. And I can kind of recreate that here. So I'm gonna go ahead and run Python here. I'm going to import, I'm gonna be at the low level here, so typing extensions. And so if I do typing, now one of the generic or attributes that Dash uses for certain hooks is the generic attribute. So if I do, or I should have done that, here, I'll make this easier. So typing extension as underscore tx. So if I do underscore tx dot generic, of course it's not gonna do it now. This project making, every project I have makes fun of me in some sort of way, and this is this project making fun of me because before it was showing that the attribute generic was not available, couldn't find it. And what's interesting is when I call the Python web server as a service at boot up, that same error still shows up and the web server fails to run. So I still had to make the change I'm about to show you regardless. I don't understand why it works from the command line though. Somebody let me know in the comments. I think, like I said, this is just my project that likes to make me look foolish here. But either way, when that error shows up, it'll show you, like when Python hits an error where it can't find a module or it can't find a certain attribute, it will give you the, it will show you the actual like file, underlying file that threw that exception. So that file is the underscore hooks.py in the Dash package. So what I had to do is, by default, the generic attribute is called from the typing extensions package, and they import typing extensions as underscore tx here. This generic attribute is also available in the typing package. So like I said, I don't know why, but for this, the web server to be able to run at boot up, I did have to change line 28 here to call the generic attribute from the typings package versus typing extensions package. I don't know what weird incompatibility is going on. I don't know if it's with Raspberry Pi, if there's some sort of like, I'm in this weird bubble of this might be fixed tomorrow and no one else would ever hit this. But if you try to run a Flask web server that uses Dash for the web interface and you get the typing extensions package does not have attribute generic, here you go. I don't know if that'll ever be useful. But the other thing that I found is due to, now the web server example in that repository is a little bit on the older side. It's from about 6 years ago. So the actual Dash package itself has updated quite a bit past that. Luckily, that didn't affect this script too much. The only thing that I had to change about this script to get it to run with the current release of Dash is to the way that it calls the Dash core components and the Dash HTML components has changed. So instead of calling it from the Dash core components package and the HTML components package explicitly, it all just comes from Dash. So I just had to change this to import from Dash, import DCC, and from Dash, import HTML. Those are the only things I had to change there. And then, like I said, maybe I should just show it on here. Do cat webserver.py. So like I mentioned, like by default, what the web server package will do is it will get what the currently assigned IPv4 IP address is of the Pi and attach the web server to port 8080 of it. However, because for troubleshooting purposes and then also development purposes, I wanted the web server attached to both the port of the local area IP that my home network assigns to the Pi, and I wanted it tied to the IP of the wireless access point it's creating. I did change that to 0.0.0. So what this will do is when you attach something to 0.0.0, it'll just attach it to all of its IP addresses, including like its local loopback IP, the IP address it's assigned via Ethernet, via Wi-Fi, an access point, all of the different interfaces. It will attach it to the whatever specified port it is there. Oh, one other thing, Flask has updated a little bit, so instead of run.server, it's just .run now. So that was the other change, but those were the only changes I had to make. Otherwise, all of this was just plug and play, brought right up. And so I thought that was a super cool stroke of luck here with this. This project came together pretty quick. So let's see it in action. So what I'm going to do is just to prove that it actually works. Let's look at it on my phone. So I will I'll have to disconnect from here. You're going to be mad at me. So just to prove that so I'm gonna disconnect my local network. So I do still have the access point up and running. Okay, so on my phone, I'll come here and connect to Rasp app. Let's thinking about it. So we are connected, and I think I had it open. So yeah, I've got the 10.3.141.1. Is this gonna be mad because I've got it open on my computer too? I know I'm not connected. There we go. My phone just had a little freak out because it's like, there's no external network or no external internet. And it's like, I know. Now I should go through and change the DAC or the Dash package to be a little bit more interactive on mobile. So I do have to turn my phone sideways here, but I'll just go ahead and run it again. So I'll enable both of my channels, do configure, and then start. And it's recording. So this was the warm hand. There we go. So we have our fully functional setup here, and we are ready to go put this in the car. So let's go do that. So I've got my mini fridge and my sleep set up, and I forgot that my little plug over here is buried. I'll insert some B-roll of it. So I had to pull all my stuff out of here. So I'm going to put the first thermocouple on the outlet here, and then the second thermocouple, like I said, I'm just gonna have out in the open to like measure the ambient temperature of the car, so I can I know how much of the measurement on the plug is just the ambient temperature floor. I don't know if that's the proper term for it or not. Yeah, so compare and contrast. Brought my setup mostly whole out here. And as you can see, I got my little standoffs here. So I need to uncoil my thermocouple cable here. I want to get the thermocouple, the actual end, down as close to the plug where it goes into the jack here. If I were smart, I would have brought tape, but I think I've got this cable's rigid enough. If you haven't worked with thermocouples before, the cable is it's like wire. It's kind of like a twist tie. It's staying where I leave it, so it's like actual wire instead of being kind of like floppy and loose. And I don't want to short out on the metal contact on the side here either. Okay, as you can see, I got the thermocouple there on the top. Careful not to touch anything to short it out. And I'm actually going to use this little door to my advantage to kind of like hold it in place there. But there we go. That is our area of concern that we want to monitor, and we are connected. All right, so now I think I'm just gonna leave, like I said, I just want this one to connect. I just want that measuring the ambient temperature of the car. So I'm just gonna leave that one where it's at. And now, which all that's left is to power it on. And to do that, I've got, so this is my battery here. I have powering everything. So powering the fridge, that's what this plug is the DC plug from the fridge. And then this cable is normally what I'm charging my phone from. You can see I've also got other just normal plugs here. So we're just going to replace it with the power cable for the Raspberry Pi, the micro USB here. Plug in the micro USB for the Pi now. There's Raspberry Pi AP. We are connected. So I still have it. Let me reload it because that's was cached from the last time. And there we go. So let's configure. And then I need to turn this sideways so you can. So we started the measurement and we are currently sampling. We're remote. We're remote and still going. It is worth noting the range on this is however far Wi-Fi range is. So while I can't get super far away, let's see how far away I can get. All right, I disconnected from the access point, stepped a little bit away and reconnected. So let's try it again. So configure, start, and we're remote. I look crazy and I'm in public. Oh my God, what am I doing? Okay, I need to go home. I need to go home. I've been in public too long. Oh my God. We're gonna try it a little bit further this time. I know I said I was going home, but definitely after this one. But I still need groceries, dang it. I'm gonna go to the second tree. Okay. All right, we'll reconfigure. Oh my gosh, it's a little bit slower, but start. Oh my God, it's measuring. It works. We're fully remote in a grocery store parking lot. Okay. I made a fool of myself in public for a YouTube video. Oh my God. A remote setup. Okay, awkward, bye. And there you have it, a in the field remote testing setup. I'm actually kind of enjoying, this has turned into like a mini series of data acquisition remote setups. Let me know if you're still interested or if you like this progression in the series. Let me know if you want me to continue this series. So leave all that feedback in the comments below and I will see you in the next video. So awkward, bye.